Hello, all. Thank you all for coming to join us on B-Sides Idaho again. This is Chase Peterson presenting wireless data analysis with Kismet and ELK. Take it away, Chase.
All right, Fallible, thank you. Thank you, everybody, for joining this. Today, we're going to talk about conducting wireless analysis using Kismet and the Elasticsearch Logstash Kibana stack. Everything that I'm presenting here is going to be uploaded or is uploaded to the GitHub repo that I've listed here. And I'll have it listed again at the end of this talk. So why are we here? What does this talk about? I want to understand the wireless environment around me. I'm a wireless security engineer. I want to see what's going on. And so how do I do that? Start off by capturing all of the RF with Kismet. Kismet's a very powerful wireless collection tool. But I want to do data analysis. I want to dig deeper into what I'm seeing. And when it comes to data analysis, Excel is awesome, but there are some better tools that are out there now. And so I started digging into some different ways of doing that, and found there wasn't a lot of documentation, first and foremost, on specifically using Elasticsearch Logstash and Kibana with Kismet. However, Kismet's been built to be able to do that. And so I wanted to present the lessons I've learned, many long nights on Stack Overflow and on page 3 or 4 of a Google search query, and put those together, provide a quick start guide to help others, and then ideally generate some interest and involvement in this. I'd love to get other insights and better ways of doing things here. So presenting the way I'm doing it, and please by all means hop on GitHub and let's make this better for everybody else. We're going to talk about Kismet collection, Elasticsearch, Logstash, Python, Kibana, how we're using all of those in this overall architecture, and then we're going to go into some of the analysis that we can extrapolate from that. And if we have time at the end, we'll test out doing a live demo. First and foremost, Kismet is the core to all of this. Very powerful collection tool, been around for about 20 years, extremely well documented, as are tutorials for using it. And so I'm not going to spend time on how to set it up in this talk, but I would recommend following Kismet Wireless on Twitter, hop on their Discord, very vibrant community there, very helpful, lots of good stuff there. And actually this week, Dragorn, the creator of Kismet, did a presentation at SharkFest where he spent a little over an hour talking about Kismet itself and everything that it does. So definitely go check that video out. Here's a quick screenshot of the new Kismet. In the last couple of years, it went through a revamp and moved to a web user interface. So you can see here, you can define your data sources, which are the different wireless cards you're using to capture. It presents all of the devices here in a table format that you can click on and get some more details. And it does some basic trend for counts of devices and things like that, so you can manage your collection system. So a lot of power here to the web UI, makes it pretty easy to get going and to use. Give you a couple examples, some platforms that I'm using for doing Kismet collection. This is lovingly called the War Box, just a cardboard box with a bunch of antennas sticking out of it. It's an Intel compute stick as the brains behind it, and has an excessively large USB hub with a series of wireless cards. In this situation, I have it set up monitoring my house environment, and so I have 2 of the cards channel locked so that they're monitoring the frequencies that my access points are using. Then I have a couple others that are doing a scan. A couple different Bluetooth devices in there, some software-defined radios. If you want to listen to the weather sensors around you, you have to install an additional dependency. It's the RTL 433 library. Pretty straightforward to install that. And then with those really inexpensive radios, you can listen to the weather sensors and other IoT devices around you. Then I have a GPS attached to this so that it's logging all of my information. And if I want to, I can toss this in the back of my vehicle and go drive around and get more data about the environment. If I don't want to carry the big box, I have a Warpack backpack. It's just a Raspberry Pi 3. It's got a couple Wi-Fi cards on it, and then software-defined radio as well, running off of a battery and a GPS, and then using these really slick BagSmart travel bags. Shove it in a backpack. I can ride it or wear it when I'm riding my bicycle, or throw it in the back of a car. Kismet has a really powerful configuration suite behind it. There's a overall document you can write, and I have an example of this on the GitHub page, so I'm not going to spend much time on it here, but you can basically define how it starts up. So in the example of the Warpack, I literally just turn it on and it starts doing everything as I wanted it to, and I don't have to interact with it at all. Kismet data. Kismet outputs a variety of data types. It writes everything initially to a SQLite database, and then it also allows you to output a couple different PCAP options that you can define. Some really powerful data processing tools are in the suite as well for cleaning up your database, dumping out your devices, exporting it to a KML or to a Wiggle CSV for uploading to the Wiggle database. And it's all built on this really powerful API that you can interact with via a curl or any other endpoints you write. There's a Python library that you can also use. There's a really useful link here. It's the if you're running a Kismet instance, it tells you all of the fields that are accessible to you. And so I have some examples here on the side. You can see here how the structure is worked by using periods to differentiate the words in the fields themselves. And so it's really important as you're doing data analysis with this to understand what the fields are and how they nest together. All of these attributes are tracked in these JSON blobs with nested fields. And so there's an example here with this .11. There's a .11.probed.ssid.ssid as the field name. However, you'll find that it typically is nested within one or two other elements, depending on the device that you're looking at. And of course, there's a field for lightning strike counts because it's a wireless collection system, and why wouldn't we be able to track devices that are also tracking lightning strikes? I thought that was a pretty neat field. Okay, to get onto the ELK stack, Elastic designed for scaling, for holding millions and millions and millions of documents, not a relational database similar to MySQL or things like that, which makes it very powerful, but also takes a little bit as a learning curve with it. Logstash is your data pipeline tool. So this is for parsing logs and files, analyzing them, doing a little bit of data mangling on them, and then pushing them into Elasticsearch. Kibana is the pretty part. It is the visualization tool that we use to interact with the Elasticsearch data. All of this is packaged together in the ELK stack. It's available on Windows, Mac, and Linux. There's a variety of license options for you. The one that I'm going to use for all of the examples here is the free and open source version. However, you can register with the license for free and get a few more features, and then of course pay to add other features and support to it. For deployment options, you can run it locally on your computer, set up your going real quickly. Bitnami creates these virtual machine images you can just download from their website. They come pre-configured. You hit go, and you have the ELK stack deployed. You can also run it on the AWS cloud, and Elastic.co is the company behind Elasticsearch. They also offer managed and self-managed services. So here's a service diagram of the walk-elk process that I've kind of figured out here over time. So you have Kismet running on the side, grabbing all of your wireless signals that are in the area. It's outputting its data to a SQLite database. When we're running live for grabbing the data to get it to Elasticsearch, we're using Logstash, which I mentioned earlier. And then we can write some Python code to post-process already written SQLite databases if we want to, which is how I'm going to use it in this example, to then feed that into Elasticsearch. And then again, we're using Kibana to visualize that. So some important terms to differentiate here. Elasticsearch uses indexes, which are similar if you're familiar with SQL. It's basically analogous to a table. And then mappings are the schemas of those tables. So you can define, I want this field to be this number, or to be a number type, or to be this other data type. Kibana uses index patterns built off of the Elasticsearch indexes. So I'll explain that a little bit more in the subsequent slides, but helpful to kind of grasp all these moving pieces here, kind of lay it out in a simple chart. Elasticsearch, when you're getting going with this, the first thing you have to do is define these indexes. Incredibly powerful. There's great documentation on it, so highly recommend digging into that. The ones I've selected here are ones I've found just in playing with it have been the most useful for me. The key part of this is defining your mappings. And what this means is saying, hey, Elastic document, and it's going to have these fields in it. You can either do it static, and that says Elasticsearch, you will only accept documents that have these 5, 10, or 15 fields. Or you can do dynamic, where you say, Elasticsearch, I'm going to throw a document at you. You're going to take everything that's in it and you're going to process it. I prefer to use the dynamic mapping, and then I limit upstream the fields that are coming in. You'll get what's called field explosion. When Elasticsearch has an index with more than 1,000 fields, it really starts to bog down and doesn't handle searches well. And if you just let Kismet go full Monty into a dynamically mapped index, I've had to get up to over 1,200 fields very quickly that it's tracking. And so it's important to mitigate that up front. And so those are some of the queries and the mutations we'll do here in a minute to help manage that. It's important to note that with your mappings, these must be defined in advance. Once the data is in the index, it technically cannot be changed. You can't change the data type. And if you have dynamic mapping on, Elasticsearch will take the first document it receives and define the data type off of that first field. And there's some issues with that. So for example, Kismet will write the channel field. If it's 802.11 wireless, it'll write it as a number. If it's Bluetooth, it instead puts frequency hopping spread spectrum text into that same field. And so the more you play with it, you'll find these errors, you'll build a little workaround for it, and then all will be good. There's a development console in Kibana that makes interacting with easy. You can write your own curl commands, but it's a lot cleaner and easier to keep track of in that development console. Testing, testing, testing. It's the biggest part of all of this, but get all the way through there, figure out what you want, and then blow everything away and start fresh, and then begin to period of time. It's hard to kind of build it in flight and keep making changes to it. Nested fields are great in how Kismet is able to capture so much data, but it creates problems in Kibana, and it can create some problems in Elasticsearch. So you got to be careful with those. Particular call out I found here is that Kibana doesn't detect these geopoint fields, the latitude and longitude fields, because they're nested. And so I had to write a workaround to pull that up into the base document so that we could visualize some of the things we'll talk about here. Logstash is really powerful since it runs as a components to it has inputs. A lot of options here. The TCP polar, just constantly running queries against the Kismet API. You have filters, which are going to do your data mangling for you, and then your outputs to Elasticsearch. Some important Kismet isms. There's some serialization points that you can access. The one we're going to access is EK JSON file format. And it basically outputs each document in one per line. Traditional JSON blows it out quite a bit more. So lesson learned on my end, you want to make sure that you point. It's also important to note here that your request your fields when you construct your queries from Kismet, you're going to ask for the fields with a dot notation. However, once it's received from Kismet, Kismet sends it to you with the underscore notation in there, so that they'll change partway through your code. This is broken down, a Logstash file broken down. I don't have time in this talk to go into the details. It's available on the site, but and on the on the GitHub repo. And there's some pretty significant findings in here as far as lessons learned. So I'll put some notes on there as to we don't have time to talk about it here. So most importantly with Logstash, make sure you document documents. There's a lot of help out there over the last 8 or 10 years or so, but the structure of Logstash and be 17 posts into an old thing only to find out that it's not accurate anymore. Trial and error, as with Elasticsearch, using repeatable test data is the best way for diagnosing what's wrong, and then get paranoid about those brackets. Can't tell you how many times I've lost time over that. Python is much more customizable and powerful than Logstash service. If you, there's Kismet and Elasticsearch built into it. You can, as part of your single script, check for, and if an index doesn't exist, push it, which makes it kind of an all-in-one tool, really powerful. And you can even do some interim analysis. It opens up all of the Python options for reading in a JSON and then conducting some analysis, aggregating results, things like that. Kibana visualizations, this will take a little bit of pattern based off of the Elasticsearch index. There's a wildcard system they use, so you can match subsequent indexes and aggregate higher level data fields. You need to remember to refresh your field indexes when you add new fields, so the Kibana visualizations will know they're there and how to treat them. Creating a visualization has a series of by defining the type that you want, selecting your index pattern, and then you can define out your metrics. So you start with your y-axis. Some ones I use commonly are the count and unique count, depending on how I want the data to be visualized. And then you have ways of bucketing your x-axis or the series and charts even within that. You can aggregate it based off of a time histogram. You can use terms. There's even some filters and a lot of things in there, depending, again, on how you want to visualize that. And then lastly, you'll adjust your metrics and axes and panel settings. I'll show you some examples here in a minute. And what you're going to do in there is basically visualize how it's going to look to optimize that. Two important fields to keep in mind are the base key, which uniquely identifies a device to Kismet, And then the base type is the technology. And so those are kind of the key ones we'll use here to build these different visualizations. You can build filters into a custom visualization, which is helpful. Things, for example, airplanes can cause some extraneous data. So you can put that into your visualization itself so you don't have to filter that at a higher level. However, don't forget you did that because that data is no longer there. And most importantly, the visualizations are tied to the index pattern you create. So when you're going through this process and you're experimenting with things, if you have to delete an index pattern, all of the visualizations that were tied to that now are broken and you have to start over. There's a backdoor way of modifying those. So just recommend getting your indexes working properly and then going back and building your visualizations on top of that. So here's some examples. This is a line graph, ice types to time. And so you can see the different colors indicate the different types of devices, so airplanes, helicopters, the different types of Wi-Fi devices, Bluetooth devices, and then the 433 sensors. And then you can see over time, a couple of these, this is where my system went down, where the pattern drops off. But I can use this to trend when devices are around me. This is running at my house um, pretty easily. This is a bar graph reflecting those same devices by the frequencies that they're, and so you can planes are transmitting 1099 megahertz, and then over here you have the Bluetooth devices kind of interspersed through the 2.4 gigahertz, and then some more Wi-Fi up in the 5 gigahertz range. This is a heat map. This is visualizing the different device types, so Wi-Fi devices to the manufacturer. So so there's some Amazon devices, Netgear, some Vizio, Wise Labs, etc. But this is just kind of density plotting the different devices. So, and a quick orientation to the visualization creation tool here. You have your search panel up at the top to define filters, time-based filters, etc. This is where it's creating the visualization, and then operations happening here on the right-hand side. So you give it your data, you define the metrics and buckets, like I mentioned earlier, bunch of options in there. Then you hit update, and it grabs the data and shows you what it looks like. Mapping. Everybody wants to put stuff on a map. There's a way to here. The mapping engine that comes with it is limited to depth of 12, which means you can only look at really a city level. If you want to go deeper, you have to roll your own WMS service. There's a really nice one I found actually for this called Map Tiler. It's a free registration. You just simply plug these values into the visualization, and you can get some pretty decent map and street imagery. So feel free to use those same settings key to be able to see that. Okay, so we built a series of visualizations. Now dashboard. This is basically all those visualizations pinned together and then working off of the same filtering system. So this allows me, I can see the counts of the devices across the top. I can see the device to time chart that we looked at, the device to frequency chart that we created. And then I can see the wireless intrusion detection Kismet is generating for me. So there's an example here where I launched an attack against my network. It's a red spike. It's hard to see in this chart, but I see a high count of DOS flood attacks, and that tells me that something suspicious happened at that time. What's neat about this is I can click and drag on the time-based charts and filter down by that, or I can select, say, for example, Wi-Fi access point itself, and then all of the other widgets will update based off of whatever filter I've applied. I'll show you an example of that here in a second. This is the spatial trends, so this is putting it on a map. This is the greater Boise area. You can see the split between Wi-Fi devices, Bluetooth devices, etc. Some of the common names. So apparently in this data set, Hilton has the most amount of points that we've looked at. We saw some Segway access points, some vehicles, some government, looks like SSIDs and things like that. And then you can see again how they're broken out across the frequency spectrum. So let's take this one step further. I want to click into this, and I noticed there was WPA3 in use, which is the newest form of encryption for wireless. Where is that at in my area that I've mapped? So I was able to click on the two types of encryption, WPA3 SAE and transition, and then all of my other widgets here filtered. So you can see now I'm down to devices that were advertising WPA3. These are the types of the access point names, Arrow, which is you can see here with the OUI counts, the most common device was an Arrow. This is a very modern, built with security in mind, access point mesh system. So makes sense that they'd already have WPA3 and there'd be a lot of them. So that's a quick way to do it. You can also do geo boxes where I can click on the map and I can select a section, and then it'll update all of my filters based off of that geographic zone. This is me looking for tile devices, Bluetooth trackers you can have. I picked up 20 of them incidentally, and you can see most of them are in that one little region. There's some advanced stuff you can do in Kibana for filters. The ADSB is what it's called. Basically, it's each aircraft has to have a responder on it. The responder transmission information. And this I can when Delta Airlines is flying, when Alaska Airlines, et cetera. So similar to FlightAware, not quite as cool as FlightAware, but data that I've collected myself and is stored locally. So to kind of summarize, order of operation when you're doing this, and this the hard way. You want to start, this is my recommendation, start by firing off Elasticsearch and Kibana. Then you're going to create your index and mapping in Elasticsearch, get that set up, configure your Logstash pipeline to pull the data, start Kismet so that it starts gathering data. Then you start Logstash to grab that and feed that into the already running Elasticsearch. Once it's in there, you create your Kibana index pattern, verify that data is loading in Kibana, and then begin to create your visualizations and dashboard. Finally, what good plan doesn't end with profits? Another screenshot of that. And with that, I'll go through some final thoughts and then demo, and we can show you some of that. So first and foremost, security. Be careful how you expose this. The reason I picked the Bitnami virtual machine is I wanted to run it locally and be able to have full control over this, not putting it up into the cloud, since this is just data that I can manage there. Trade-off with that is my laptop goes to sleep, as you can see, and I miss data. So there are proper ways of securing it in the cloud. That was not in the scope of this initial presentation. So if you're going to do that, make sure you're very careful about how to do that. GitHub. So please, I'm adding some examples, less quick start guides up there. Feel free to hop on and pull it down. Tell me what's broken or what's not working for you. If you have any questions, feel free to reach out. I'll leave my contact information up here. And since I've got a few minutes left, go ahead and switch over and give you guys a live interaction here of the dashboard. So this is the dashboard running. I'm going to hit. You can see my time tickers move a little bit. If I want to narrow down on a time zone, click in here and can filter down. You can see it's going to narrow down the number period. I can click in here and look at specific act. I can zoom in and only, or if I only want to see where the Wi-Fi access points are across the rest of these examples, I can filter down by this, and I can see the most common access on my house gear. These are the different SSIDs that are being broadcast, and these are the channel where those are at. This is an example of that GeoTrends dashboard, the map of the different things that I've seen. You can see 100,000 devices that I've mapped in this area. I can draw a box and only grab, oh, mouse is failing me here. Grab just a short section up here in the corner, and you'll notice device types, count, common names, etc. will all update based off of that narrowed down field. And so in this specific area, it looks like this is the schools are in the area, most common access point there. Apple's the most common device, followed shortly Google, and then looks like again the Aero systems and devices out in that area. If we wanted to do some larger trend, add a custom filter, and I can say manufacturer. I can filter down by a specific. And I'm going to type in, let's look for Roku devices here. And what this is going to do is plot out based off of the OUI. And of course, it's going to fail because I'm doing a demo. Let me edit that real quick. There we go. What's a good presentation without a hiccup? Okay, now what I can see is distribution of Roku devices. We got a bunch of clients and then a large grouping of Wi-Fi direct devices. 463 have been mapped to the area. And you can see actually the distribution across the area. So the Roku is pretty common in the Boise area. You can do the same thing with other types of manufacturers. Tesla, a lot of the vehicles will advertise keywords in their names. You saw the My Chevrolet earlier. So with that, I will open it up.
Okay, thank you very much, Chase. Sorry, everybody, about the choppiness. It looks like it was between Chase and I on the Discord side. There's not much I can do to fix that, unfortunately. So we did have a couple of questions come in. Chase, so when it's working, what tool consumes most of your time? Elasticsearch, Kibana, or Kismet, both set up in operations time?
Oh, good question. Once it's most of the time is spent in Kibana, and that can be with either tweaking your indexes. Logstash was probably the most miserable to get figured out, but once it's figured out, it runs pretty smoothly.
So once you get that one up and going, did you find any good guides on that, or have you produced any guides of your own that you can link to when the talk is over?
Absolutely. So there's quite a bit of documentation on that. A lot of it first figuring out what you want to do. There's just a lot of people trying to do a lot of different things with any one of these tools. I put together some quick start steps in on the GitHub page, and I'm beginning to pull in the good tutorials I find that are current, and I can put those in there as well. Definitely.
Gotcha. Hey, so I think you mentioned this briefly at the beginning, but where did your data come from? Are you actively out war driving? You can maybe even show that slide of the your rig again.
Absolutely, yeah. So get back to the right one here. So what I was doing, actually, DEF CON summer test village at DEF CON was to go out and do war driving, and so that was what built a system similar to one of the, and then just went out. Typically, when I'm running errands, I'll toss it in the background. But the reason there's so much data is I was deliberately trying to map areas for the wireless CTF.
That's perfect. I love it. We'll do probably the last call for questions here. I see a couple of people typing, so in the meantime, I really love the work that you've put together on this one. There's a lot of what you have built in this presentation that I know I personally, and I think a lot of other people dabble in wireless things, and we go, this is a thing I'd love to learn more about, but don't really know where to start. It's something you seem to very much need a project and some kind of end goal in order to know how to dive in. So I love watching that you have built something that's very approachable, and it seems like something that people can jump into at maybe a slightly lesser level, but about this level, and accomplish something. So if people end up with questions and thoughts and want to approach you on this one, I think that your contact information is available on our website, but if you're up for that, would you like people to reach out through Twitter or hit you on your GitHub? How would you like people to talk?
Yeah, absolutely. I'll put up here. I have the Twitter Discord channel. I'll be up on Discord as well, and then the GitHub issue tracker is great for the if you have questions specifically on the code that's in there. So yeah, definitely, please feel free to reach out. You're right. It all starts with asking a question, right? And that's the best way to then figure out what you need to do and where you need to start. So figure out what you want to know, and then you can work backwards to find the right tools and ways to do it.
Excellent. All right. So no additional questions on this one. My final one for you would be, what is the one takeaway at the end of your presentation that you would like just everybody to make sure that they took away? What's the one thing you want them to learn from this?
Dive deeper. Keep digging into find problems, tackle them, and the answers are out there. You just got to figure them out, and then share what you know so that everybody else learn from your painful mistakes.
That was a great presentation. Thank you very much for coming to join us. If anybody has any questions, the contact information is up here. You can continue to drop some questions in the Track 1 chat if you'd like. And I want to say thank you very much.